All right, let's get real about AI for a minute. We're going to cut through all the hype and talk about a choice that every single person in this field has to make. Which tool do you actually use for the job? Is it always the biggest, baddest, most complicated model? Well, let's find out. So, let me just start with a direct question, and I want you to be honest with yourself. Are you an AI snob? Do you automatically reach for that super complex deep learning model because you think bigger is always better? In the real world, that's often the fastest way to get things wrong. At the heart of this whole discussion are really two main families of machine learning. You've got classical ML on one side. This is the reliable workhorse. It's been powering tons of applications for years. And on the other side, you've got deep learning, the heavy lifter, the one that gets all the press for its incredible power. But how do you know when to use which? To make this choice totally clear, we're going to lean on one simple but really powerful analogy that's going to guide us through this whole explainer: the industrial crane versus the good old-fashioned screwdriver. Just think about it. Classical ML is your screwdriver. It's precise, it's super reliable, and it's absolutely perfect for specific, well-defined jobs. Deep learning? That's the industrial crane. Yeah, it's incredibly powerful, it can lift unbelievable things, but it's also expensive, takes forever to set up, and it is complete and utter overkill if all you need to do is tighten a single screw. So how do you decide if you need the screwdriver or the crane? Well, it's not some kind of dark art. It really just comes down to asking four key questions. This is the practical framework that will point you to the right answer pretty much every single time. Okay, first things first, you gotta look at what you're working with. What's the nature of your data? Is it all neat and organized, or is it kind of messy and all over the place? And honestly, the answer here is usually pretty clear. If your data fits nicely into rows and columns, think of an Excel spreadsheet, then classical ML, or screwdriver, is almost always your best bet. But for the unstructured stuff like images, audio files, or just raw text from the internet, you're going to need the heavy lifting power of that deep learning crane. The second question is all about scale. I mean, are you working with a few thousand records, or do you have a literal mountain of data that you need to make sense of? And you can see the relationship pretty clearly here. Classical ML models are great, but their performance kind of hits a ceiling after you feed them a certain amount of data. Deep learning models, on the other hand, we call them data hungry. The more data you throw at them, the better they get. Their performance just keeps on climbing. Now, this next question, this is the one that tech folks sometimes forget, but it is absolutely critical in the business world. Can you explain why your model made the decision it did? We call this interpretability. And here's the kicker. Classical models, they're transparent. You can literally pop the hood and see the logic. The model can say, hey, this loan was denied because the person's income was under $40,000. Deep learning models are often a black box. They give you a fantastic answer, but if you ask why, the best answer you'll get is because the math said so. Not super helpful for a business. And finally, we have to talk about the practical stuff. What kind of computer power do you actually have? This is a question of pure, simple pragmatism. The difference is night and day. You can run most classical ML models on a totally standard laptop, and it'll probably finish in a few minutes. They're cheap, they're accessible. Deep learning, though, that requires specialized, expensive hardware. We're talking powerful GPUs, and training can sometimes take days. That's a huge investment of both time and money. Okay, so we've got our four questions. Now let's stop talking theory and see how this framework actually holds up when we apply it to some real-world problems. Time to put it to the test. Okay, scenario one, we're building a tool to predict house prices. Let's run down our checklist. The data, it's in a spreadsheet, that's tabular. The data size, pretty small, just 5,000 homes. Do we need to explain our price? Absolutely, buyers will want to know why. And the hardware? Just a standard laptop. So what's the verdict? This is a total slam dunk for classical ML. Every single one of our questions points directly to the screwdriver. Using a massive deep learning model here would be like bringing that industrial crane to hang a picture frame. It's just the wrong tool for the job. All right, scenario two, we're building an app that can tell the difference between a picture of a cat and a dog. So, data type, images, that's unstructured. Data size, large, 50,000 of them. Do we need an explanation? Not really, we just need it to be right, and we have access to a beefy GPU. And the recommendation here is just as obvious, but it's pointing in the completely opposite direction. This is a job for the heavy lifter. The complex, unstructured nature of images is exactly what deep learning was made for. This is crane territory for sure. Okay, our final scenario, and this one's a little tricky. We're detecting credit card fraud. The data is tabular, it's transaction logs, but the size is huge, over 1 million transactions. And we have a GPU, so you might be thinking deep learning, right? But look closely at that third point. We must be able to explain our decisions for legal and regulatory reasons. And this right here is probably the most important lesson of this entire explainer. The verdict is classical ML. Why? Because that business requirement, that need for an explanation to satisfy legal teams, it completely trumps everything else. It's more important than the massive data set. Sometimes a business role is the only thing that matters. So what's the big idea here? What's the main takeaway? It's about adopting a different mindset. It's about being a pragmatist, not an AI snob. It's about following one simple yet incredibly powerful rule. And that rule actually has a name, Occam's razor. It's a principle that's been around for centuries, and all it says is that the simplest solution is almost always the best one. Don't make things more complicated than they need to be. So what does that actually look like in practice? It's this workflow. Step 1, always try a simple model first. Step 2, see how well it does. That's your baseline. And step 3, only if that simple model isn't good enough for your needs should you even think about reaching for a more complex tool. Start with the screwdriver. Always. So the next time you're starting an AI project, just ask yourself this one simple question. Are you building a birdhouse or are you building a skyscraper? Because if you can answer that, you'll know everything you need to know about which tool to pick up. Choose wisely.